guys, Mr. Starry again. Today I want to take a look at solving one-step add and subtract equations. Remember, the purpose of solving any equation is to find the value for the variable that makes the equation true. So again, we need to ask ourselves, what number plus 5 gives me 17? What number minus 8 gives me 2, right? 16 equals what number minus 4? And this is kind of the goal here, is to kind of do some work to figure out, okay, what value goes there. Now, some of you are probably sitting there going, oh, well, I can obviously see that the answer to this is 12. Why? Because 12 plus 5 equals 17. Oh, I can look here. The answer is 10. 10 minus 8 equals 2. And you'd be absolutely correct. However, what is good when things are kind of simple and straightforward like this is to take some time to practice our solving form. And that's kind of the purpose of today's video. So there's two kind of layers to this, right? We want to solve for x, and that will kind of give us our answer, but we also want to focus on our solving form. Remember, what we're doing is we're kind of like unwrapping this variable. We want to take away what we see. So again, we kind of have this variable plus 5, but how do I make that go away? Remember, the key to solving equations is doing the opposite of what you see or what you're trying to get rid of. So for example, let's jump right into our first example, right? Good solving form, it's always good to draw like a separating line at the equal sign, and that kind of breaks our equation into two halves, and now we're ready to go to work. We focus on the side that has the variable on it because, you know, this is the side where I'm trying to get this variable by itself. And how do I do that? I do the opposite of what I see. Well, I see plus 5, so in my mind, I need to do minus 5. And what that does is that zeroes this out, right? So all I'll be left with over here is the x, and that'll be equal to something. Now, you've heard this probably before, but equations are like scales, right? A balancing scale where whatever we do to one side of our equation, we have to do to the other side, because if we don't do that, then we're changing the value of a certain side of an equation, and that kind of breaks things. So we got to be consistent here. And a good way to look at this is if I do it on the left side of my line, I need to do it on the right as well. Well, now I just have some math to do, right? This is kind of handled on the left side. 17 minus 5, that gives me 12. And that would be your final answer. Notice my variable is alone, and I kind of have just a single value on the other side. Now, we can always go back and check this, right? We now have our value for x, so we can substitute this 12 back in just to check to make sure that we did our work correctly. I'm not going to do this for every example, but it is a good way to check. So we go, we're going to take this x out, and we now know its value is 12. So is 12 plus 5 17? It is, so everything is correct. Let's move on to number 2. We draw our separating line. We look at the side that has our variable on it. Notice we see a minus 8. Minus 8, how do I undo minus or subtract? With addition. And again, the goal is to zero that out. Whatever I do on one side, I have to do to the other. And we're kind of set up to finish here. Notice all I have left, now that this becomes 0, sometimes you'll cross it out. Some teachers teach it that way. But all we're left with, the important part is all we're left with is the x. And now we just have some math to do. 2 plus 8, 10. Quick check, 10 minus 8 equals 2. Moving on. Again, draw our line at the equal sign, but notice our x and our variables on the right side this time, but that's okay. It doesn't change what we do. Our focus just starts over here now rather than being on the left side like it was for the first two examples. Well, what do I see? I see x minus 4. I'll do plus 4. Why? To make this 4 or this minus 4 or negative 4 go away, right? We can cross out if that helps. But remember, we have to do plus 4 over here as well. Now we're ready to do some math. 16 plus 4 is 20. Equal sign kind of just rides down, and all we're left with on the right side is x. Quick check. 20 goes in for x. 20 minus 4 equals 16. For our fourth example, we have kind of the same idea. Again, just splitting at the equal sign, focusing on the side that has our variable. Notice we see a plus 3, so in our brain we need to be thinking opposite, minus 3. And again, we're going to do that to both sides. Notice that my 3's will cancel. I'm left with x equals, and now just a little bit of math to do. Negative 9 minus 3, which is negative 12. Things are kind of switched around in number 5, but that's okay. Now, we can think of this in two ways. We can either flip these terms around so that this becomes x plus 4, and then kind of treat it like one of our first two examples. Or we can kind of come to the understanding of, hey, I need to make this positive 4 go away. And how do I do that? I subtract 4. The goal is to make it 0 out. Well, I've done that now. So again, to the other side, and I'm left with positive x, right? I like to think of that plus sign as positive when I'm writing my next kind of line here. My equal sign rides the line, and I'm going to do 25 minus 4, which is 21. Last but not least, again, things are super flipped around in this one, right? We have our x term on the right side. We have kind of this negative 3 plus. And again, we can think about this in two ways. I can rewrite this as positive x minus 3. Notice that the sign follows the term, okay? Or I can say, hey, what do I need to get rid of? I need to get rid of this negative 3. How do I get rid of it? By adding 3, right? The goal is to make it 0 out. And again, what are we left with? These cancel out. I'm left with x. My equal sign rides down. Negative 8 plus 3 should give me negative 5. That's just a quick overview of how you solve add and subtract one-step equations, but that's all I have for you today in this one, guys.